G'day, fellow casting nerds. This video is a redo of a presentation that I did for the Fly Fishers International in early October. At the time that presentation was made, the guys at Fly Fishers International said they were going to release the video or release the presentation on video so that people could see it. That was done in early October. It's now early December and they haven't released that yet. So what follows here is my redo of that presentation. And I know it's a long video. There's probably quite a lot of questions you've got. If you do have questions, put them in the comment section below and I'll get to them as soon as I can. So sorry it's a long video. I hope you can stay till the end, and then I'll speak to you at the end as well. All right. So today I'm going to talk about the importance of tension in the cast. There is slack versus tension. So this discussion is going to be about the difference between the two. Obviously, we know what those are. The standard model of casting mechanics, I'm going to cover that, and then I'm going to deliver an alternative model of casting mechanics and how to make use of tension in the cast. I'm also going to talk about how we teach casting by focusing on tension. And the premise of the presentation is that many of us are missing half the story when we teach the casting stroke. The casting stroke is the rod motion sufficient to cause loop formation. That's the definition in the FFI. A loop control doesn't end at loop formation though. Slack and tension are end members of the same characteristic of a cast. And concentrating on slack alone obscures the value of tension, particularly the value of increasing it rather than simply establishing tension. The 5 essentials that casting nerds all talk about are these: the straight line rod tip path, SLP, the correct application of power, a variable casting arc, variable pause length between strokes, and the elimination of slack. Now, these 5 essentials are things that we need to make a successful cast in general terms. Instructors are looking for these, and when we're teaching our students about casting, we have the 5 essentials in mind most of the time. But what about if we eliminate slack with maintain tension instead? It's essentially the same thing, but it's a different way of looking at the same property. This presentation broadly focuses on what we could be doing as the loop unrolls during what we call the pause, so between the strokes. For most people, the cast is a series of pulses back and forth, each followed by a pulse in which we are passive observers. Now, we tend to think of casting as a series of pulses where we're doing something and then we're pausing, and then we're doing something and then we're pausing, and then we're doing something and we're pausing. So during the casting stroke, we're doing something, we're casting with the rod, and then we're simply waiting for that to unroll before we do something else again. I don't think that's a terribly good way of thinking about how we actually should be casting. We should be distributing the actions we take throughout the cast, or concentrating not just on making the stroke, but doing something between the strokes. So we should be casting and then waiting and casting and waiting, but it's all part of the same thing. We are not just casting and waiting, we're casting and doing something. And that doing something is actually maintaining tension or even increasing tension. So a bit of a sidetrack here. In the physics, the tension is described as a pulling force transmitted axially along by means of a string. A tension might also be described as the action-reaction pair of forces acting at each end of the string. And the ends of the string will exert forces on the objects to which the string is connected, in the direction of the string at the point of attachment. And there's basically 2 possibilities for systems of objects held by strings. Either acceleration is 0, and the system is therefore in equilibrium, or there is acceleration and therefore the net force present in the system. There is a net force present in the system. So if we're seeing acceleration, it means that there must be some net force happening. So the catenary is a shape that we see of strings or ropes or chains or wires under the action of gravity and in tension as well. Right, so we're seeing it in this location here. This shape here is what we call a catenary. We have a post and we have this thing hanging down below. Now obviously a chain has a bit of mass to it, so it hangs. We're seeing it on this bridge here. we have the ropes or the cables in tension, and these in tension under gravity, and also in tension against the end members here, and that is holding the bridge in place. So the weight of the bridge is being supported by these cables in tension. In the cast, we're also seeing that same shape here. The rod leg has this shape here. Now I've cast very slowly here, and with a slow cast, we aren't getting much tension from the rod leg, from the fly leg, which is up here. I'll talk about that a bit more. But this accentuates this catenary shape in the rod leg. So the sources of tension in a cast. We get air drag on the fly and the extremity of the fly. This is minimal. There isn't a lot actually happening up here, and I'll show that more in the next slide. But we also have tension at the rod tip. You can see the rod's a little bit bent there because we've got the weight of this string and the tension in this string pulling on the rod tip, which gives us a little bit of a bend in the rod there. We also have gravity acting throughout the rod leg, pulling because the fly line has a bit of mass, so it's going to be pulling itself down, or gravity is going to pull it down. And we also have tension from the fly leg pulling the rod leg at the loop nose, and that amount of tension gradually decreases because we have a taper at the end of the line here. So we have the fly leg pulling on the loop nose, which adds tension at this point here. So the sources of tension are gravity, and then we have a tension at the rod tip here, and here's that shape we talked about before, the catenary, and we have the fly leg pulling on the loop nose. So it's not just stop and wait. We actually do have some tension in the in the rod leg. We'll see it here on the next cast as well. Make the cast. The rod tip lifts up a little bit here, and you can see that's tension in there, and we have that particular shape that we talked about before. The fly leg pulls on the loop nose. And we have a transverse wave traveling through this rope as well. All right, so when this guy moves the rod, moves his hand, he puts, here's that shape I should say. We're talking about the shape here, the catenary shape. It happens here. Let's replay that. Doesn't want to replay. All right, I can't make it replay, but you did see that wave travel through the string. And so here, the velocity of that wave that travels through the string is dependent on the square root of the tension and the linear density, which is basically how much it weighs per unit length. So the velocity of that wave that we saw traveling through the string is proportional to the tension in the rope and inversely proportional to the linear density of the rope. Move on to the next one here. So if I make a cast here and I tap the rod here, you can see I've put a little wave through here, and this wave travels through the rod leg as we saw in that previous thing because there is tension in the rod leg. Now I'll see if it'll let me do that again. Yes. When I tap the rod, it puts a little wave in the fly leg, in the rod leg here, and that travels along the rod leg through the line because there is tension in this line. So we can add tension after loop formation, and this is something that I think is quite vital to casting, and you'll see some of the best casters in the world do this. They may not recognize that they're doing it, but you'll see them do it if you look for it. Now what I'm talking about here is just a little bit of lift in the rod tip. Now I've attached my fly line to another rod here, a fiberglass rod, so you can see just how much tension a little lift in this rod tip produces. If I just lift that rod tip up, you can see it's really pulling on that, and the line is straightened because I've added a lot of tension to that line just by lifting the rod tip up. I didn't lift it very far. I haven't pulled it all the way back here. It's mainly gone from this location here up to about this location here. You can see that bend in the rod in my hand, and it's adding tension to the line, which is pulling the rod over here. So in a typical sort of cast, if we add a lot of speed to the cast, we get a lot of tension happening in the rod leg because, and I'm going to pause this here, and we just move it along a little bit, because this fly leg is pulling on the rod leg through the loop, and there's a lot of tension happening throughout this cast, mainly because I'm casting so fast, much faster than I would like to cast. But you can see that I've put in quite a lot of effort. I've made that string quite tight through there because I've cast very fast, and this fly leg pulling on the loop nose puts tension into the rod leg, which then puts a bend in the rod in the fishing rod. I'll do it here quite fast again, another fast cast, and that was the presentation cast. So I've pushed a lot of effort into the cast, and when I stop the cast, drop it down, the tension gradually decreases. So the conventional model of casting is what I just talked about there, where the line in the fly leg pulls the rod leg at the loop nose via a tight loop. And we all accept that. We all understand that the faster we cast, the harder this line is travelling and pulling against the loop nose, which adds tension to the rod leg, which is felt at the rod tip. So that is, fast, tight loops add tension, and we all know that. And when we want to cast far, we have to cast fast. So here's a less conventional approach to the mechanics of the cast. When we're not talking about necessarily how fast we've cast, but what we've done with the cast after we've made that cast. So when I move the rod tip sideways, I produce a wave in the fly leg, and that travels away from the rod tip towards the fly, which is down here somewhere. So when I move that rod sideways, I put a wave in here that travels away from the rod tip towards the fly leg, towards the fly. And there's tension in this as I'm doing this against gravity, and that tension has actually pulled the fly from way over here somewhere back up underneath me here. And you can see as I move the rod sideways, those loops, or these waves, are traveling from the rod tip towards the fly. And if I pause a little bit longer between each movement of the rod tip, that has the opportunity to move that loop further away from the rod tip. Until I start moving the rod tip back over here, that's going to keep moving that direction. The longer I pause, the longer that wave travels through the string. And you can see it's traveling further and further as I wait longer and longer. Now eventually, if I wait long enough, that movement of the rod tip produces what we know as a cast. But it's still a wave traveling from the rod tip towards the fly. So here's the little wave. It's getting bigger and bigger because I haven't moved my rod tip any further. And eventually, that just becomes what we know as a cast. I haven't done anything different with the rod tip. I've just waited longer between each movement of the rod tip. So that's a little bit different to what most people believe was the mechanics of the cast. So I use a program called Tracker to do some physics analysis of my casting. And you can see here that this looks like a typical wave pattern where we go from to the left of the screen, to the right of the screen, to the left of the screen, to the right of the screen. And it has a period of about 1.5 seconds between each cast. Is that 1.5? Let me just check that. Yeah, roughly 1.5 seconds between leaving here, going over here, and then coming back to here. And that's the same as the period that I'm doing with my rod tip movements. The longer I pause, the further it goes. Now I can do this on any part of this fly line, and I'll get a longer pause between if I have my examination point closer to the rod tip. I get a big pause through here where it doesn't move very far, and I get this sort of square wave form through here. But when I have my examination point, or the point of interest, closer to the fly, it appears to be a wave. And we can measure the period, we can measure the amplitude. It's essentially a wave. So let's think of it as a wave. I know that a lot of physicists will be looking at this saying, this isn't a wave. That's fine. For the purposes of teaching people, I think of it as a wave because the things that I do with my rod tip to influence the tension in the cast are the same things that you would do if it really was a wave. Now, whether it is or not, I've had quite a lot of arguments with this about this with people. I don't particularly care for those arguments. By teaching casting as if the loop is a wave, I'm getting great results. So here we have 3 typical casts. The first cast is where I've made the rod tip come forward. Now, we're not getting any there. So let's see here. So the rod tip moves forward. I haven't lifted the rod tip. I've actually dropped it after I've made my loop. You can see the rod tips coming down. And my maximum rod tip speed during that cast was 5.2 meters per second. And the maximum speed that the fluff gets to on the end here is 8.5 meters per second. And this is the graph of that. Now, cast 2 is made, and I recognised afterwards that I did actually lift the rod soon after I made the cast. I've lifted it back up to here, and I probably shouldn't have done that. But at this point it's staying steady, and that rod tip doesn't move. And essentially we're getting a 5.6 meter per second rod tip movement, and the fluff is travelling at 9 meters per second. So roughly the same there. This time I'm going to lift the rod tip after the loop forms though. So instead of just keeping it there, I'm going to keep lifting it up. And when I lifted it, the fluff actually went to 13.5 meters per second, even though it started at somewhere between these two, exactly between these two. Lifting the rod tip up added significantly to the speed that this fly, the fluff, travelled at. So when I made that cast, this is dropping the rod tip. You can see it's coming through here, and then it gradually increases, the fly increases. In the second cast, it stays essentially the same, but in the third cast, when I'm lifting the rod tip up here, through here, you can see as I lift it, that fluff gets faster and faster, and it reaches 13.5 meters per second, significantly faster than what you'd expect it to be. You'd expect it to be around about 8.7, 8.8 meters per second, but lifting the rod tip has increased my fly speed. So that's telling us something about what's happening in the fly, in the cast. Now here I'm rapidly pulling my rod tip back during this cast to add huge amounts of tension to the cast rather than just let things happen. I pull the rod tip back rapidly at this point here, which slows the loop nose but also rapidly increases this nail knot in this case, and it reaches 40 meters per second. So we started out with a rod tip speed around about where was it? Let me go back here. So this was a fast cast, so the rod tip speed would have been around about 8 meters per second. But when I pull the rod tip back during the cast like this, that rapidly increases the speed that the fly travels through the air at. And so adding tension increases the speed of the fly across the ground. So here's another view of that. But if we were an ant sitting on this fly leg, sitting on the fly line, and here's the ant here, the loop is traveling towards the ant, and then the loop's at the ant, and then the loop's traveling away from the ant. Now that speed that loop's traveling through there, the apparent speed for the ant of the loop, goes from about 5 meters per second through to up to about 33 meters per second. That's just the speed that loop or that wave is traveling through the string towards the ant here. So as I add tension, that wave travels relative to the fly leg much, much faster. Relative to the fly line, I should say, much, much faster. So what we're seeing here is the velocity of the wave, which is the loop, is proportional to the tension and the density, divided by the linear density of the rope. Basically how heavy the line is. So these are all just waves in the string. Now I'm going to pause this one in a sec, so we bring it back here. So the first wave happens here. You can just see that rod tip just start to lift here. that produces a tailing loop. It's hard to see it here because, oops, stop there. It's hard to see it because it's here. It's traveling along the string away from the rod tip. And this is the tailing loop here, but you can't see it quite yet. You can just see it start to really develop now. That's it there. There's the tailing loop. Now here is the loop nose, which is another wave. And I'm going to put a wave in the rod leg right there. So here we have a wave in the rod leg, a wave which we call the loop, and a tailing loop. As we move those further through the cast, as time develops through this cast, all three of these waves are travelling through the line at roughly the same speed. Here's the tailing loop, here's the loop nose, and here's the wave in the rod leg. Right, so you can see they're basically travelling through the line at essentially the same speed. Not across the ground at the same speed, but through the loop, or through the line at the same speed. So, first wave there, second wave there, third wave there. And we see them travelling through the line from the rod tip to the fly. And the importance of that is that no wave can overtake another. So none of those waves overtake any other wave in there. The tailing loop can't overtake the loop, and the loop can't overtake the tailing loop, and the wave I've put in the rod leg can't overtake the loop. So none of these can overtake each other. They all stay in roughly the same position in the fly line throughout the cast. They might change their shape, but they're all roughly in the same position in the fly line. So let's have a look at the roll cast as a wave. This one's a bit more obviously a wave. It's travelling from the rod tip towards the fly. Now, these first two casts, I don't have much tension in the line. Do another one. I've just let the line go slack after I've made the cast. So hit it, make a circular looking wave that rolls along the line, and I'm not adding any tension, and so that loop just dies. That wave just dies in that cast. Now in the next cast, add a little bit of tension. So a lot of tension at the start where I've lifted that rod quickly, and then when I drop the tension, you can see that wave just stalls. It was going really fast while I had tension in there, but then it just stops and doesn't reach the end goal. On this one, I'm going to pull the rod tip back quite a lot after I've made the cast. When I keep pulling that back, you can see that wave travelling through the string all the way to the end. In fact, it accelerates at the end there because I've added more tension to that string. So I'll just show those ones again. Just pause that, and you can see here this one travels through and then it basically dies. When I drop the tension here, move the rod forward, you can see that wave just stops and stalls. However, this one, as I add tension here, keep adding tension, that wave travels much, much faster through the string towards the end. So what are some applications of this idea? Keeping the rod tip up helps maintain the tension. So when you keep the rod tip up, you need less effort during the stroke to make the cast. So if I drop the rod tip down like this, yeah, the cast makes it because I can cast okay and I can reach that sort of distance with a bit of effort. But I can use less effort if I keep the rod tip up, and I still get a better looking cast with less effort during the cast. So keeping the rod tip up until the loop reaches the nail knot roughly, I can keep a lot of tension in that line with less effort during the cast. And that will force what we call turnover. We don't actually, all we're really doing is forcing that wave to travel through the string faster by keeping the rod tip up. So you can use less effort to make the cast work if you keep that rod tip up during the cast. Loops look better too, but that's just a side benefit of it. When you drop the rod tip down, you can see here, stop there, that catenary that I talked about earlier isn't really working anymore. There's not much tension in that fly leg anymore. It's still there, because if it wasn't there, then the loop wouldn't be traveling. But when I lift the rod tip up, I get more tension in that cast. Here's that shape that I talked about, the catenary. I get more tension in the cast, which forces that wave to travel through the string towards the fly. I can use extra tension by lifting the rod tip up during the back cast to improve my back cast. And during this cast, I normally make my back cast, lift the rod tip up like that, and then I drop it down again just before I make the cast, so I maintain my casting arc. But lifting the rod tip up during the cast allows me to carry much more line during that back cast. And it also allows me to make a very good presentation on the back cast by lifting that rod tip up a little bit during that back cast presentation. If I just make the cast, lift the rod tip up, it forces the loop to travel through the string faster, and then I drop the rod tip just before I make that presentation cast, or just before I make that presentation, I end up with a nice straight line. You can use tension to lengthen the carry that we do. So if you've got a long head line like a double taper or maybe a Mastery Expert distance, if I keep that rod tip up, this cast, I can carry a lot more line in the cast during that cast if I keep my rod tip up. Now you can see I've lifted it there, and now I'm going to drop it a little bit and make my forward cast. Lift the rod tip up here significantly. That forces that wave to travel through the string faster. And then if I want to make a presentation, I can drop that rod tip at that point there. So using tension helps increase the carry for our long casts. Now we make a tension. I'm going to pause this one here. In a typical pick up and lay down cast, we lift the rod tip up. That creates the tension. It forms the tension. It also moves point P away from us, and it lessens the amount of line that's sitting on the water, so it reduces the anchor. So less tension there because the tension's now in the line. We've also moved the rod tip, the rod close to where we want to start our casting arc, but the first thing we do is establish tension by lifting the rod tip up. Then we make our cast. Then if we keep the rod tip up here for as long as we can, and then drop the rod tip just before we make our presentation cast, we can have beautiful tight loops all the way through with less effort during the cast, and control exactly how fast that line or the loop runs through the fly leg, or runs through the rod leg. Runs through the fly line, not rod leg. So yes, if we keep our rod tip up, this is dropping the rod tip intentionally, here's our target here, we lose control of that loop as soon as we drop the rod tip. We haven't got control over tension. But if we keep the rod tip up during the accuracy cast, say for the CCI exam or the MCI exam, we can maintain very good speed throughout that cast with less effort during the cast. Now, when I recorded this, the MCI task accuracy was without a haul allowed, and it has since been changed so that haul is allowed in the accuracy because a lot of people couldn't reach that 50-foot mark. Now, if they had been keeping the rod tip up during the cast like this, it's much easier to reach that target. So even without a haul, that would have been a nice cast. I like a haul. I fish with a haul, so I'm always going to use it. But keeping that rod tip up allows you to keep control of what that loop is doing, because you're maintaining tension in the fly line. When you maintain tension in the fly line, that allows you to maintain control over that wave. So tasks 4 and 5 in the MCI exam are examples of horizontal transverse waves that we added to the rod leg after loop formation. These are just more waves that are in the fly line that we've added after we've formed the loop. The rod tip is moved laterally, left and right, after loop formation. The wave travels along the rod leg at the same pace as the loop, provided tension is maintained in the rod leg. So that's pretty important. When you make your loop, if you start making wiggles in the rod leg, they will travel at the same speed as the loop throughout that cast, until the line straightens. Now, those are the wiggle ones I'm talking about. If we just do sorry, I shouldn't have been talking about the wiggle ones. I should have been talking about the aerial mends in tasks 4 and 5. When you move the rod, say, out to the left and back, that will put a mend in the line that travels along the rod leg and travels at the same speed as the loop. So the sooner you make that movement with the rod tip to the left and back, the closer that stays to the loop, and it will stay there throughout. Now, if you maintain tension for too long, that mend will travel out of the rod leg and you'll lose it. And obviously we don't want that. So keeping tension helps deliver the wave further from the rod tip. The 35-foot mend is more easily achieved with a high rod tip. Keep that in mind. So here we've got some wiggle mends. Now I've slanted the wiggle mend so that it's diagonal rather than horizontal, just so that we can see it in this cast. Ideally I would have had an overhead shot to show what a wiggle mend looks like. But when we do this cast, I form the loop and then I start putting the wiggles in, and each one of these wiggles stays about the same distance from the loop as it goes along. Now, if we keep wiggling after the loop has gone out, we start to pull the fly back because we're adding extra tension that's pulling the fly back towards us like we did on the ladder earlier. So we really don't want to do that. Controlling underpowered curve cast. Dropping the rod tip during this cast will cause the loop's progress through the line to stall because the tension is removed. So once we drop the rod tip in an underpowered curve cast, the loop, a wave, stops moving through the line. If we lift the rod tip up lifting the rod tip will force the curve further along the line, and we may not want that, but we may need it in case we didn't cast quite hard enough to make the target. So controlling the tension with the rod offers a way of controlling the curve's location after the stroke has been completed. So we made the stroke, we're not stuck with what we produced during that stroke. We can still control it a bit more after we've made the stroke by controlling what the rod tip does. So here's an underpowered curve cast. When I drop the rod tip, I stop that loop traveling through the line, and you can see it just collapses and it falls to the ground. That's what we're trying to achieve with an underpowered curve cast. Do it again. Drop the rod tip now, and that will slow the wave's progress through the line, allowing us to precisely place the loop where we want it to go. Now, overpowered curve casts. One of the ways we can do this is smacking it. We don't really want to do that. But if I lift the rod tip straight after loop formation, I'm adding extra speed to the wave traveling through the string, and then when I drop the rod tip, I slow it down. That produces an overpowered curve cast, in this case to the left, where so I've made my loop horizontal, and then when I lift the rod tip up, I dramatically increase the speed that the line is traveling through the air at. Right, we'll see it here. Lift it, that's pulled this line, and then when I drop the rod tip, let's just pause it and come back to it here. So here's my loop formation. It's a horizontal loop, so it looks very, very tight. When I lift the rod tip immediately after loop formation, I'm increasing the speed that this wave travels through the string. And then when I drop it, adding slack or decreasing tension, this wave no longer travels through the string as quickly and allows this to catch up and overtake it. And we end up with a overpowered curve cast that bends to the left in this case. And that's through controlling tension at the rod tip. So dropping the rod tip from here to here has slowed the speed that wave travels through the string. So how about when we're teaching a student? So this is for instructors. When we teach a student to reduce their total power output, one of the best ways to do this is to cast as softly as we can. Now these are quite soft casts, and normally it takes quite a lot of casts to get it slow enough to demonstrate to the student that we're trying to cast so softly that that loop just fails to reach the nail knot. Now that's too much power, so I'll do it again and cast it even softer this time. As long as the rod tip's kept high, this task is nearly impossible. But during the progress of this task, the student will end up making beautiful loops because they just get to the right amount of speed for this amount of line. Forget the dolphin noses there. They're coming from shock on the rod. Now I normally, during this demonstration, I usually have to cheat because, as I said, it's very, very difficult to stop that loop reaching the end. Now I don't cheat as much as I've done in this video in this cast here, but I normally drop the rod tip down and say, have a look at that loop. See how that's failing there? That's what we're trying to achieve. Now what I did there was cheat. I've told them during the build-up that they must keep the rod tip up during the cast to make this cast, to see if they can reduce the amount of effort they need. What I'm actually doing is getting them to maintain tension by keeping the rod tip up. If you've got enough speed to form a loop and you can maintain tension in that line, this loop will always reach the end. But if you drop the rod tip like most of us do, you end up with a loop that fails to reach the end because this wave can't travel through the string anymore. The wave stalls. You can see these black lines on here. These black lines black marks I put on the fly leg. On the fly line. You can see that this loop just can't travel through the string anymore. That wave just can't travel through the string when you take the tension out of the string. So my cheat is to say, just like that one there, and it crashes. Usually the student doesn't see me pointing at the rod tip, at the loop, or they see me using the rod to point at the loop, but they don't realize that what I've done is drop the tension in the string. When you drop the tension in the string, the wave fails to reach the end, so the loop fails. The takeaway from that is that when you are casting, you want to maintain tension. It's much easier to make that cast work if you've maintained tension throughout the cast. So the minimum power drill helps us to illustrate the concept of the loop as a wave. We use prior learning from the tin can telephone, where we have no tension and no wave in the string. So if we're talking through here and there's slack in this string, this kid can't hear it. So minimize power during the stroke tends to minimize the opportunity for incorrect application of power. And remember, that's one of the five essentials, correct application of power. It turns out that when we use less oomph, we get more finesse, we get a better cast. Controlling the loop after the stroke with rod tip manipulations more evenly distributes our time in control of the cast. So it's not just hit it and wait, hit it and wait. We hit it and we control it. We hit it and we control it, and we hit it and we control it. So to establish tension, we cast tight loops at the targets. This is what we all do. We cast with higher line speed. We use higher line weight. But to maintain tension, we need to keep the rod tip high after loop formation until the loop nearly reaches the nail knot. We use the last portion of the fly leg's momentum to pull the slack from the rod leg as the rod tip is lowered during the presentation cast. Nearly all students lower that rod tip way too soon in the presentation cast and lose that tension. We've all seen it, the spin fishermen amongst us, which is nearly all of us before we started fly fishing, make that final presentation by really opening up that stroke, and we end up not only widening the loop but reducing the tension that we get. So the cast is more likely to fail if tension is not maintained. But what about increasing tension? Increasing tension should make that wave travel through the string faster, and it does. So one way to increase tension is cast across the wind, where the wind blows the rod leg tight for us. So it's very hard to make those minimum tension casts if there's any wind around and we're casting across the wind. The check haul is another way to increase tension. So gravity's effect on the rod leg tension naturally increases throughout the cast. So the longer the cast, the more mass is in the rod leg, which means more tension. So that, as long as we can carry, then we can actually get a pretty good amount of tension. One other way, and this is my favorite way, is to lift the rod after loop formation. And I'll demonstrate that. I'll show you somebody doing that shortly. The loop can be considered as a wave traveling through the line from the rod tip to the fly. Loops can't travel through the line when tension is removed. They'll always travel through the line if there is tension. And the higher the tension, the faster the loop travels through the line. And the higher the tension, the faster the fly travels across the water. So casting into the wind is very much easier if we maintain tension. That is, additional line speed is not the only way to successfully cast into the wind. Keeping tension in the rod leg enhances conditions for the wave transmission. So try it yourself. Get out there, cast into the wind, but instead of just casting as hard as you can, try casting by keeping the rod tip up. You'll find that cast into the wind is actually quite a bit easier than you might have thought. Keep the rod tip elevated throughout most of the presentation cast. This is the number one takeaway. A little lift goes a long way. So here's Christopher Rounds. He's got a video called, or Marcus Size has a video called In Search of the Perfect Loop. He gets the perfect loop by lifting the rod tip during the cast. So he makes the cast there and he lifts the rod tip, and you'll see it on this one here. Lift. That little lift after loop formation makes that, and we'll see it here, cast lift. That tightens that loop, makes that cast so much better. So I'm going to go back to this one first cast here. So you see here, this is just a switch cast, makes the cast forward, and then after loop formation, lifts the rod tip here. You can see it started down here, it lifts it to here. That tightens that loop. Oh, sorry, not just tightens the loop. What he's doing is adding tension to the rod leg. And when you add tension to the rod leg, you make that wave travel through the string faster, and then he delivers the perfect cast. So he didn't have to do all that much effort during the cast, but then lifting the rod tip after the cast makes that wave travel through the string faster, makes the cast a beautiful cast. Now, anybody casting spey casting should be considering that rod lift after loop formation, but it also works on every other cast that you're doing too. Roll casts, overhead casts, all the spey casts, delivery casts. Keeping tension in the rod leg using the rod tip is vital to making these casts work. Now, I've called this slide the perfect lift, and he's in search of the perfect loop, but he gets the perfect loop, in my opinion, by lifting that rod tip after loop formation. So the cast isn't over at loop formation. If you lift that rod tip, you can make that cast go much more powerfully, much more gracefully than if you had put in a lot of extra effort during that cast. So we can control the cast after we've formed the loop using the rod tip. As with any wave in the string, modifying tension alters the speed of transmission of that wave. Controlling our tension is our way of controlling the loop. Less tension equals less control. No tension equals no cast. All right, so look, I'm sorry that was such a long video. It was a long presentation to put together. I hope you got a lot out of it. Tension for me has been one of the revelations in my casting in the last couple of years. It's revolutionized the way I cast. It's revolutionized the way I teach casting. So please go out and try some of these things for yourself, especially the minimum power drill, casting as softly as you can while keeping that rod tip up. See if you can stop that loop reaching the end. It's very, very difficult to do, especially if you keep the rod tip up. The way you can always make it not reach the end is by dropping the rod tip. So when you're casting, keep your rod tip up until the very end of your cast, and that way the loop will always reach the end of your line. All right, good luck.